Hello everyone and welcome. This video will see what is bias variance trade-off in machine learning. So let's consider an example here. Here, based on the years of experience, want to predict the salary of the employees, right? Based on the years of experience, we want to predict the salary. So here on x-axis we have the experiences and on y-axis we have the salary of the employees, and these are our data points. So as we can see, as the experience increases, the salary is also increasing. So we want to build a model, let's say a linear regression model here, that tries to fit a line that can better estimate this salary based on the years of experience of that employee. So here we have drawn this line which is closest to all the points, right? So here this line fits our data perfectly, right? So here there is less difference between the actual and the predicted value. So we are going to have a less error, right? So we are having less error here. So here our linear regression model does a very good job, right? As we are getting very less error when we are predicting any value. All right. Now let's consider that we have built this linear regression model and now I introduce some new data points, right? So as we all know, as the years of experience increases, salary also increases, but it reaches a point where the salary does not increase any further, right? This becomes plateau. So we have this new data points, let's see, right? So here we have this new data points, right? So here our model, if you see, the line is predicting the higher salary, but all these data points where we have introduced these new data points, these are below this line. That means the predicted value is higher than the actual values, right? So there is a huge difference between the actual and the predicted values here. You see, here we have this large error, then again there is a big difference between this actual value and the predicted value. So we are having a huge difference between the actual and the predicted value. So our model is predicting larger value than our actual values, right? It is predicting a large salary amount than is in actual, right? So our model here is making an assumption that as the year of experience increases, a salary also increases, but this is not the case always, right? So our model is making a assumption here that as the year of experience increases, the salary also increases. So when our model makes this simplifying assumption about the data, we say that our model is highly biased. Say that our model is highly biased. So we are having high bias, and this high bias leads to high error in the actual and the predicted values. Have high bias and it leads to high error as well. And this is not the condition that we want our model to be in, right? Not the desired result that we want from our model. All right, now let's consider another example, right? So we have years of experiences on the x-axis and the salary on the y-axis, and these all are our training data points which are in blue. All right, now let's say I have trained my model enough. Let's say after 1000 of iteration of training, I have come out with, so we have trained our model enough that it fits through all the data points. All right, so it fits through all these data points. So it has memorized all this relationship and all these values that is there in the training data. All right. Now, here we are going to have a low training error because this line passes through each data point, right? So we are going to have low training error. Now let's say if I introduce the new data points that my model has not seen before, then it is represented in green color. Then if you see, there is a very big difference, right? There is a very big difference, the actual and the predicted value, right? So here have introduced new data points that our model has not seen before, and there is a big difference between the actual and the predicted value. So we are going to have a high testing error. So when we test our model on the unseen data, it is going to give you a high error, right? So this model does not generalizes the relationship, rather it has fitted and learned all these data points, all the values that are there in the training set. So it hasn't produced a generalized model capturing this relationship. So here we have a high variance, between our actual and the predicted value. So we have high variance, and this is not the desired result that we want from our model as well. All right. So now the question is, which model shall we consider from the two? The model with high bias or high variance? Now the simple answer to this is we cannot consider any of the two models. So we cannot consider model with high variance and the model with high bias, right? So the ideal model is the one with low bias and low variance. So we want a model that has low bias and low variance, but that is quite rare in the real world. All right. So there is something called as bias variance trade-off. So there is always a trade-off between this high bias and high variance. So how do we overcome this problem? Let's say if your model have high variance, that it fits through all these data points, then try to introduce some bias in your model. So you introduce some bias when there is high variance, and when there is high bias, you try to make this model more complex, or you try to add some variance in your model. So this is the bias variance trade-off in machine learning. I hope now you are clear about that and you can answer it quickly the next time that anyone asks you. Thank you and stay tuned.